Today we will talk about exceptions handling. An exception is an event that is raised when an error occurs during program execution. I am sure that by this point we have all encountered them more than once. The main problem with exceptions is that when they are raised, then the work of our script at this happy moment is rudely interrupted. A simple example. In the body of the main function, I want to create a dictionary where the key will be website and the value will be a Google page, for example. D is the result of the dict function, and the website parameter gets as the value the google.com, for example. And on the next line, I will try to get from this dictionary the value of a key that does not exist. Well, let's say it'll be the URL. The URL. And after that, on the next two lines, I want to ask Python to do something quite normal. Let's say add two numbers and print the sum. 1 plus 1, print sum. And I want to call the main function. And let's run the script. And I got a key error exception. There is no such key in the dictionary. At the same time, the work of the script was interrupted and it did not execute quite normal lines with the addition of two numbers. When a script interrupts, this is always at least annoying, but it can also lead to the loss of processed data, or if you have a web application, that causes it to stop working. In any case, the key point in working with exceptions is that they interrupt the script and we need to do something about it. Because our script should work no matter what and correctly react to exceptions. That is, in the situation when an error occurs during the execution of the script and an exception is raised, we should be able to switch to that block of code that will do what we need during this exception. For this, the Python language has a try except construct. The syntax is simple. The code in which we assume an error may occur, we wrap with the try block. And the code that should be executed when an exception is raised is written into the except block. I want to get the URL, to try to get on the URL, and otherwise I want to do this. At the moment when an exception is raised in the try block, Python cancels all actions that lead to the occurrence of this exception and passes control into the except block. A familiar picture, I am sure. And it looks a lot like a conditional statement if-else. So let's run the script. And as you can see, this time I got 2. I want to change a bit the except block to make the example look a little more real. The URL will be The example is quite sketchy. In fact, as you remember, dictionaries have a number of methods that allows us to omit of using try except when reading values. This was done on purpose to reduce the amount of code. These methods are get and set default. Okay. The except statement is a generic statement. That is, it catches in general all exceptions that may be. But if you specify the name of the exception after the except keyword, you can catch the exception of the specific type. For example, I had a key error exception raised here, so I will indicate it explicitly. Key error. This statement says that I will only catch exceptions of the key error type. nothing changed. Everything works exactly the same as before, okay. But now, in the try block above getting the key, I intentionally make a different type of error. I will try to print the value of a variable that is not defined. And let's run the script. And this time we can see what happened. An exception of the nameError class was raised because I used an undefined variable. What to do? In addition to catching key error exceptions, you can put one more except block and catch the nameError exceptions as well. Or you can return a common except back to catch any other exceptions. We can see here the message of the nameError exception. Let's divide by 0 something here. And let's run the code. And we can see that this time the common except block has worked. Some other exception. What does it give to us? This gives us the ability to control which code will be executed in a given exception, in a given situation. As I said, a single except clause catches any exceptions, including exceptions that are thrown when we interrupt the script with the keyboard shortcut Ctrl and C. It means that if we would like to interrupt the program with the Ctrl C, it will not work, because this exception will be cached too. In this case, it is advisable to catch the exception. The exception is the base class for any other exceptions, and this expression will catch all exceptions as well, except for the program termination exception, and the Ctrl and C key combination will work. Additionally, with the try block, you can also use the completely optional finally block, which is always executed regardless of whether an exception was thrown or not. It's most often used in the combination with except, that is, try except finally. Its meaning is that the finally block is executed before the moment the raised exception is passed to the calling code. Here. For example, in the except block I want to print some message that I am in the except block. For example, here I want to print something like inside the except block and the URL variable. And after that I want to return the URL variable using the return keyword. Return URL. The return keyword interrupts the execution of the function and returns the result of the function to the calling code here. It means that the code after the return keyword won't be executed. And here I want to use the finally block, which is printed or does something very important before the control of the program flow will be passed to the calling code. And now at the bottom I will assign the returning value of the main function to the result variable, for example, result, and print it. And let's run the code. Python tried to find the specified URL key and couldn't find it. The key error exception was raised and caught, and the control flow passed into the except block. Here, inside the except block, or close, the URL variable got this value. And also this message was printed. But before the URL value was returned to the calling code here, the finally block was executed. And we can see this message. And only after the finally block was executed, only after that, the main function returns the value from the except block. Such is the design. What it can be used for? What are these actions that should be performed in any case? This is the release of all kinds of resources, like memory or the closing of what needs to be closed, file objects, database connections, coroutines, etc. But to perform all these actions, the context managers are usually used. The with context manager of the context manager decorator from the context lab module. Therefore, finally block is relatively rare. The try except block has one more optional else block, which is executed only when no exception occurs. And in my practical Python web scraping course, I use it a lot. In fact, the else clause is also the try block. Why then is it needed? The thing is, it's a good idea to use only one line of code in the try block, where the exception might be raised, because by putting more code in the try block, we increase the likelihood of hard-to-catch bugs. After all, if any exceptions errors occur in other lines of code of the try block, then we won't know about it, because they will be catched. But what if there should be more actions? And the answer is simple. Move the rest of the code into the else block, which will be executed if there is no exception. Example with the else clause. I'll take the same function, the main function, and add the else block here instead of the finally. And inside it, I will call the upper method of the URL variable and assign its result to the URL variable again, upper. That is, I will override the URL variable. Also, I want to remove the returning value, and I want to comment this print. And let's run the script. Okay, because I have no returning value. Okay, let's add the returning value here on the level of my try except else blocks, and I want to return the URL. And let's run the code again, and we can see this address, https://google.com. That the URL variable got in the except block because the exception was raised. The D dictionary has no URL key. Okay, let's add the URL key. And let's run the code again. And this time the else block was executed and I got the URL string in uppercase because no exception was raised. Once again, why else is needed? It's needed not to clutter the try block. If we put everything in try block, then we simply will not see an exception that we have the wrong data type in the dictionary or the data was not correct. Whether we need to see such an exception or not depends on the situation, but in any case, we must very clearly understand and be aware of what is happening, and if an error occurs elsewhere, then it is also desirable to know about it. And therefore, the else block can be very useful. The next video will be about Python modules and rules of importing. If you like this video, please leave a like and subscribe to the channel. Thanks for watching.